Hello all, it's Steve from MFL Bison Ranch Limited again. Just standing here in front of a few of the beehives we have here. I say few, this is most of them. We've got 36 beehives here from a local beekeeper on our ranch. We just did this year. We've had some bees on the ranch for a while. We've got 4 hives of our own. But because we're trying to regenerate the polyculture, native polycultures on our ranch, it's good to have good pollinators around. We've got leafcutter bees, we've got mason bees and all that kind of stuff that live here naturally. But add in, I don't know how many honeybees you got there, 30 to 60,000 per hive, 36 hives plus the other 4, so that's quite a few honeybees. Anyway, I'm not going to count them all, so I'm not going to stick a number out there and have everyone question me. But anyway, a lot of bees, and yeah, so we, commercial beekeeper, he keeps his bees here. We then have the option of buying the honey back from him, and then we can sell it in our store. So it kind of works for us and works for him, and yeah, we get some honey. This year wasn't particularly good. It was too cold, but anyway, we'll get a bit of honey. Probably around about 50-60 pounds out of each hive, and so that'll be good. It's a good quality ranch honey. Comes off of lots of clover and hairy vetch and a whole bunch of native flowering species. Anyway, there's our honeybees. But that's not why I want to talk to you. I want to talk to you about the claim that livestock's bad for the environment and is emitting a lot of greenhouse gas and contributing to climate change and all that kind of stuff. Now, whatever you think about the whole climate change hypothesis and it's being fueled by CO2, the idea that livestock are a major contributor to that is something that I want to talk to you about. And there's a reason for that, and it'll become clear. But rather than me just telling you what I think, what I'm going to do is I'm going to get you to confirm the numbers that I'm going to give you, so that there's no confusion or argument here. So what I'm going to ask you to do is hit pause in a second and go find some information. First off, what I'd like you to do, find out how much methane a 1,200-pound beef cow produces per year. Then find out what the CO2 equivalent of that CH4 emission is in terms of kilograms or tons. Then find out what percentage of her body mass does she consume in dry matter forage each day, and find out what percentage of that dry matter forage, the grass and forbs and legumes that she eats, what percentage of that is carbon. Then find out, because we're talking about grasslands here, which is probably 90 to 95% grasses and the rest are forbs and legumes and a few sedges and things. Find out what percentage of that average grass plant is below ground and what percentage is above ground. What else you're going to need here? Find out the atomic mass of CO2, so the atomic mass of CO2 and the breakdown of the atomic mass of carbon, the atomic mass of oxygen. And then find out what the digestive efficiency of a grazing ruminant is. So wildebeest, Cape buffalo, bison, beef cow, whatever, it doesn't matter, they're all pretty much the same. The smaller ones are slightly less efficient than the bigger ones, but anyway, they're all within a couple percentage points. Find all that information and then come back to the video and we'll move on. Pause. Okay, welcome back. Right, so let's have a look at this. We're talking about a 1,200-pound beef cow. It doesn't matter, we could talk bison, we could talk Cape buffalo, we could talk wildebeest. They're all grazing ruminants, and they all come from wild populations originally. Bovine cattle originally come from Europe and Asia. We have bison here, that's the North American variation. But they do the same thing. They're still a walking sauerkraut vat. That's effectively what they are. They're a walking four-wheel drive sauerkraut vat, as Joel Salatin calls them. And here's the thing. If you found out the information, you'll find that 1,200-pound beef cow emits about 100 kilograms of methane each year. And that's the equivalent of 2,300 kilograms or 2.3 tons of CO2. So there you go, that's a fair amount. Got 100 cows out there, man, that's a lot of methane and a lot of CO2 equivalent, lots of people would say. However, let's have a look at that same beef cow. She eats 2.5% of her body mass per day on average. That means out of dry matter forage, she's eating 30 pounds a day, or when we work that out, it comes out at just over 10,000 pounds, or 4.97 metric tons. Okay, so she's eating 4.97 metric tons of dry matter forage a day. That's the forage minus all the water that's in it. And 50% of that's carbon, roughly speaking, give or take. Some people might say it's 45, but whatever, let's say 50%. Because the numbers you'll find out won't matter within a few percentage points. 50% carbon. So she's consuming 2.49 tons of carbon per year. Pure carbon, not CO2, pure carbon. And her digestive system is only 20% efficient. That means that only 20% of the carbon that goes in gets turned into energy in cow. The rest goes out the back end in the form of manure. So effectively that sauerkraut vat is pre-composting 80% of that dry matter forage and putting it back on the field as compost, known as manure. And that cow pat or cow pie, depending on which side of the Atlantic you are, sits on the ground for about 6 weeks before it disappears completely, if the soil biology is healthy. And that's a key, if the soil biology is healthy. All the bugs, so you're talking about the dung beetles, you're talking about little worms, you're talking about fly larvae, you're talking about all the microbiology, the microarthropods and everything else, will take that stuff into the soil in about 6 weeks. In an unhealthy environment where the soil's not healthy, where we've messed it up, it can oxidize away for 5, 6, 7, 8, 9, 10 years, and that's volatilizing, that's oxidizing. That carbon is just going back to the atmosphere as CO2. But in a healthy environment, the biology is taking it down. 6 weeks later, it's all gone. So let's just say, for example, that only 50% of that ends up in the soil. You're now talking about 995 kilograms of carbon have just gone into the soil. And if you convert that with an atomic weight of carbon of 12 and oxygen 16, the CO2 equivalent, you can work out mathematically, of that 995 kilograms of carbon comes out to 3.65 tons of CO2. So she's emitted 2.3 tons equivalent, and she's just stored just through grazing and digestion, putting it on the ground, she's stored 3.65 tons. So she's already a carbon negative cow. Now, in a proper holistically grazed rangeland, about a third of what she eats, of the grass that she goes over, is eaten. And another third is trampled, and the rest is the green leaf matter that allows the plant the photosynthetic capability to regrow. Now, it's not perfect because no cow ever just grazes 1/3 off of every plant, but in general on a paddock, that's what you manage for. You manage for a third of the consumption. If you do that, about a third of it gets trampled. That gets pushed down on the soil surface, and the same biology, or not the same biology, but the biology that's on the ground is taking that and digesting it into the ground. It's being broken down biologically going into the ground. And if only 50% of that ends up in the ground, because you're talking about another 4.97 tons of biomass, you're ending up with another 4.56 tons of CO2 going into the ground. So overall, we're talking about 8.2 tons. So she's emitted 2.3 tons, and 8.2 tons has gone back into the soil in the same process. So is the cow carbon positive or carbon negative? I would say the cow is carbon negative. So there's something else going on here. And there's another bit to the story. That grass plant, if you worked out what percentage of it is below ground, what percentage is above ground, you'll find that 75 to 90% of it is below ground. It's all root. It's not like a tree where what you're seeing is all the stored carbon above ground. In a grass plant, all the stored carbon is below ground, most of it. 75 to 90% of the biomass of that plant. And stored in those roots are carbohydrates. And when that plant is damaged, i.e. an animal bites it, and this is a natural process, they've co-evolved to do this. When the animal bites that plant sends a signal to its roots, and it fires root exudates out into the soil. Those roots can be 15 to 25 feet down with these fescues and bromes, but mostly the fescues, way down, proper perennial prairie grasses. Some of them have gone down as deep as 40 feet, but let's say 15 to 25 feet. They fire out root exudates. That is simple sugars, carbohydrates, and a little bit of protein. It pumps carbon into the soil because that's what the soil biology eat. And the soil biology comes to eat that carbohydrate and protein that the plants put out there, and that biology brings with them all the nutrients the plant needs for regrowth, the mineral nutrients out of the soil. Biology gets into a fight, the microarthropods eat the little bug, eat the bacteria, all that kind of stuff, releases all that nutrients, the plant absorbs them into the root and fires them back up to the top of the plant to regrow and grow new leaves and start off the whole growth system again. So there you go. Every time the plant is bitten, it pumps carbon into the soil. If it is then given the proper rest period to grow back to full expression and supply the root system with that carbohydrate storage, it's then bitten again, it does the same thing. It pumps more carbon in and then regrows. Pumps more carbon and regrows. And the important thing to remember, the physical structure of that plant is 97.5% elements that come out of the air. Water, carbon, nitrogen, and a couple of trace atmospheric elements. Only 2.5% is actually mineral elements out of the ground. So soil grows from plants. Plants do not grow from soil. What we're actually seeing is the bit of the plant that's absorbing the real nutrients. The real nutrients for plants comes out of the air. That's the thing you need to realize. Plants grow out of the air, not out of the ground. So there you go. You now have a carbon pump. So in addition to that 8.2 tons that the cow is putting into the soil through direct action, through trampling and defecation, she's also stimulating the plants to act as a pump. And in this environment, early season, every 30 days it can be grazed. Late season, every 45. So roughly speaking, 3 or 4 cycles in each growing season where we live here in central Alberta. So you're pumping a fresh wave of soil carbons in 4 times in every season as that grass is grazed and then rested and then grazed and rested. So more going in. Something over the 8.2 tons that the cow's putting in by herself. And this is the thing. There's lots of people saying these cows, they're terrible for the environment, but actually they're essential to it. If you don't have those grazing ruminants on this land, you end up with biodiversity loss. They're keystone species. It doesn't matter whether it's a cow or a bison or whatever, the megafauna are required. If you go back to the early Pleistocene, so we're talking about prior to the current Pleistocene ice age known as the Quaternary, back when we had when all these huge grasslands that cover 70% of the world's surface, these seasonal grasslands were created, we had 2.5 times the biomass just in animals that we currently have in terms of animals and humans today on Earth. 2.5 times. They didn't destroy the environment when they were here. They built all the world's topsoils and all the world's plant ecosystems. That's right, those animals built those ecosystems. The complex interrelationship between grazing herbivores, predators, and plant ecosystems and the soil ecosystems underneath them built the topsoil that we survive on today, that all of our food is produced off of. Modern agriculture destroys it, but ruminant agriculture, i.e. livestock agriculture, certainly doesn't, as you can see from the numbers. Well, it does if it's mismanaged, but if it's properly done, it doesn't. It can't, because it's mimicking the natural system that created the topsoil in the first place. And to illustrate that further, when you get off this, I'd like you to Google Quantis, Q-U-A-N-T-I-S. It's an independent research organization. Google that and white oak pastures. And they did a life cycle analysis on white oak pastures, which is a regenerative ranch in Georgia, that for every 1 kilogram of beef they produce, they put 3.5 kilograms of carbon into the soil. And they've done that since 1994. And it's well documented, well tested. That's 12.8 kilograms of CO2 into the soil for every kilogram of beef produced. That's what properly managed livestock are capable of, because that's mimicking the natural cycle of nature that created topsoil in the first place. And get this, that 3.5 kilograms is only tested in the top layer, because when we do soil testing, most soil testing is only done in the top 12 inches of the profile, roughly speaking. You'd have to check that. I can't remember off the top of my head how deeply you tested in that life cycle analysis. But I mentioned to you earlier, those grass plants, the roots go down 15 to 25 feet. We're not testing that deep. But when that plant is bitten and it fires off those soil carbons into the soil, yes, the higher amount goes into the upper soil, but they're putting out root exudates into the soil all the way down. And that means that we're building carbon a long way down, right? So higher levels at the surface and decreasing levels they go down, but all the way down to the bottom of those roots, we're putting carbon into the soil every time that plant is cycled through its life cycle. Okay, so 3.5 kilograms only in the top bit. How much carbon is being put in below? Right, 12.8 kilograms of CO2. That's what livestock are actually doing for your environment. When you support regenerative rangeland agriculture, you go buy your grass-fed beef, your holistically managed grass-fed beef or grass-fed bison or grass-fed Cape buffalo, whatever, whatever people are growing, goats, sheep, right? If they are managed properly, that's what you're doing by supporting that type of agriculture. Look for regenerative, because regenerative ag is putting carbon in the soil. It's not cropping. The soybeans that your tofu and a lot of your plant-based proteins are based on, soybeans are the 3rd most destructive crop on Earth. Arable agriculture is the single most destructive human activity in terms of destruction of natural wildlife habitat on Earth, bar none. Rice is the worst, cotton is a second, soybeans number 3, and all the other grains and pulses, so your peas and your corn and all that sort of stuff come not far after that. But soybeans, just purely production of a soybean, that's without any processing, puts 2 kilograms of carbon into the atmosphere for every kilogram of product produced. That's 2 kilograms of carbon, not CO2. So it's a lot more CO2, 7.5, 8 kilograms of CO2, something like that. So you cannot use monoculture agriculture to achieve what properly managed livestock can do. Now, where livestock goes wrong, and this is where a lot of the modern system's gone wrong, is we grow monocultures to feed livestock. That's ridiculous. Should stop, right? That is bad. But that's not the livestock's fault. They're not bad for the environment. We are. The people who mismanage them, humans that mismanage livestock, humans that mismanage any of the natural ecosystem to grow the wrong kinds of food that A, we're not meant to eat, and B, the environment is not meant to grow, i.e. all your grains and pulses and all that kind of stuff, that is where the emissions are coming from. They're not coming from the cow. Because you can sit down and you can go through those figures that I just gave you all day long, and you'll find you won't be able to make a cow carbon positive. They're not. They can't be. It's impossible. Because those grazing ruminants, they created the ecosystems that we love to look at today. These diverse polyculture grasslands and deciduous forest ecosystems. They were created by ruminant animals. And so I'll leave that with you as a little thought, but go through the figures, prove me wrong. But the reality is, cows can save the environment, if you want to put it that way. But they aren't wrecking it. It's humans and mismanagement of all the resources we have that cause the problems. But the actual cow, she'll save the planet. When we're long gone, they'll still be here doing what they've always done. And the world will be a better place for it in some cases. Anyway, go to your local store, buy some grass-fed beef, buy some grass-fed bison, buy some grass-fed anything, some wild game, because that is what is going to restore our natural ecosystems and provide healthy food for you and your family. Thank you very much.